Hello, my name is Ben Sellers, science teacher at Grady High School. Today I'm going to review with you Newton's second law lab. The purpose of the lab is really to overview how a teacher should instruct a middle school or high school lab activity. If you're interested in the lab itself, you can see the contact information below. I'll be happy to email it to you. So, first thing is I'll discuss with the students what we're going to be doing. Today we're going to be experimenting with Newton's second law. I think having them on the Promethean board helps the students see where they're supposed to be. I also would hold this paper up and display that the students should be looking here on their paper as well. First thing we'll do is we'll start off by reading over the purpose. The purpose of this lab is to determine the relationship among force, mass, and acceleration as stated in Newton's second law. It's important to read over the purpose of a lab. Students oftentimes just do labs because they feel like they're given a list of instructions to complete, but they need to know why they're performing the lab. Next, we're going to read over and display the materials. Not enough just to give the students the materials and assume they're going to know what in the world is going on. So, it says materials, Hall's card. That's this little blue thing. A string, as you can see right here. A spring scale. A meter stick, which I have laid down here. A ruler, or what's a meter stick? And masking tape. I have masking tape here. After you identify all the materials by holding them up and showing the students, go ahead and move on to the procedures. Now the procedures are going to start with number one saying, place a small piece of masking tape down as your starting line. And that's right here. Now I've already placed a small piece of masking tape down as a starting line for mine. It says take the cart, extend the cart so the string is tight. This is number two. Attach the end of the string with a loop to the spring scale. I've already done this. Place 100 gram mass into the cart. This is 100 gram mass. It even says 100 G on it. So we're going to place it in the cart. Hold the cart in place at the starting line while your partner pulls back on the spring scale until it registers 1 Newton of force. This is a good point to emphasize that partnership is really needed in this lab. So I'll pull the spring scale back to 1 Newton. It says the next procedure says release the cart. Be careful not to pull the cart with your hand once you've released it. This may interfere with the results. So I've got it at 1 Newton right now. I'm going to release the cart. Now it says measure the distance the cart moved from the start line and record your data in the table below. It's right here. At this point I'm going to point out the data table. Table 1. It says trial 1 distance. And at 1 Newton, this is exactly what we just did. So I'm going to measure my distance. This one's 16.5. So it's 16.5 centimeters is what I would write here. Then I'm going to go back and do another trial. I want to emphasize to the students that they're going to do 2 trials at each data point. After that, they'll need to add these up and divide by 2 in order to find the average distance. This would be a good point to re-emphasize how to collect average as well. As you believe it or not, several students will not remember how to calculate average, so never assume that they know how to do something as simple as that. Let's see. They'll need 2 trials for each variable. Point out the independent and dependent variables. Okay. The independent and dependent variables for this lab are going to help them in order to graph the data, which is really going to be a big point of the lab. Independent variable is the variable that you're changing on purpose, and dependent variable is the variable that you're measuring. So the independent variable that we're changing on purpose in this data table is the force. So this will be your independent variable. That means it will go on the x-axis. The dependent variable is the data point that we're actually collecting. So that will be the distance that the cart travels. So that'll be on your y-axis. After you explain how to do that, go ahead and move on to procedure B. That will be the second part of the lab. How does varying the mass affect the distance traveled? It says repeat the basic procedures above, but keep the force at 5 newtons and vary the weight in the cart. So if you flip over to the back of your paper or in case of the Promethean, you just go to the next page. Here's table 2. Now in this case, our variables have changed. Our independent variable at this time is how much mass is in the cart. So that's what will go on our x-axis. Our dependent variable is still the distance the cart traveled. Now, what seems to be confusing to students oftentimes is that there will be 2 different graphs. This is not going to be a double bar graph. It's not going to be a double line graph. There are going to be 2 different graphs because these are 2 different sets of data. Now, you're going to explain to them that this time they're going to pull it back just like they did the original time, but they're going to be modifying the mass. And they'll have to have a mass set. 100, 200, 300, 400, and 500. Pretty straightforward. Collect 2 sets of data, collect the average again, and then they'll be graphing the averages. Give students about 25-30 minutes to complete the lab and go ahead and let them graph that data as well. That should be a simple graph, and it is a bar graph, as stated in number 1. Question 1 says, construct a bar graph of average distance versus force and a graph of average distance versus mass. Notice the and's all in caps. And this will help them understand that there are 2 graphs required. So about after 25-30 minutes, I would conclude class by having students graph the data on the Promethean board. I would bring a graph up on the Promethean board, just a standard graph paper. You can review scale at this point as well. What students to start with on the graph, what the graph should go up to as far as centimeters, and so forth. So, after graphing, point out the big picture of the lab. What's the big picture of the lab? That's something that's very, very critical as far as understanding why you're doing a lab. If I add more mass but keep the force the same, how does that affect the data? Well, students will see with their graph that as you add more mass with the same amount of force, the cart doesn't travel as far. The graph will show this. Inversely, the graph from data table 1 will show that as you add more force but keep the mass the same, then your data will show a trend of up. So this will help students see that if I add more force but keep the mass the same, then Newton's law, second law, is being obeyed. So F is equal to m times a, right? As mass stays the same and acceleration or force is increased, it should accelerate further. And therefore, the distance goes further. After that, that's basically the answers for question 3 and 4 on the analysis questions. It says what happened to distance, what happened to distance, 3 and 4. So do your results support Newton's second law? Absolutely, they do support Newton's second law, and have the students explain them. So a good little follow-up as far as like assessment-wise, you could either collect the lab, grade the graph as well, which is always a good activity, or you could just have a simple little quiz, 10-15 question lab quiz on Newton's second law. Hope that's helpful, and thanks for watching.